Everything in this universe is made up of small elementary particles, but if we ask what exactly are these small particles, your teacher says out of syllabus. But the real reason is that we don't exactly know what a particle is, but we have theories, and I am going to discuss 3 of the most widely accepted theories. A particle is a collapsed wave function. Suppose there is a kid named Timmy, and he has 2 types of balls. One is the classical ball, and other is the quantum ball. Timmy likes to throw his balls at his neighbor's window, and Timmy has 5 neighbors. Suppose Timmy uses his classical ball to break the window of his 3rd neighbor. Now as long as Timmy's aim is not feces of a dog, and the ball breaks the 3rd neighbor's window, it will surely and obviously land in his 3rd neighbor's house. But if instead Timmy uses his quantum ball to break the window, something unusual happens. But that unusual thing only happens when Timmy throws his quantum ball blindfolded. When Timmy throws his quantum ball blindfolded, he hears noises of cracking and shattering of multiple windows at the same time. When Timmy removes his blindfold, he notices all 4 of his neighbors' window cracked and one completely shattered. The neighbors had enough of Timmy that day. They beat the living balls out of Timmy, and takes Timmy to their secret basement. Now we don't know what happened with Timmy that day, but we do know what happened when Timmy threw that quantum ball. When Timmy threw the quantum ball at his neighbor's window, it transitioned from being just a regular ball to something you can call a probabilistic quantum ball wave. In simple words, the quantum ball spreads throughout the space just like a wave with different probabilities of being found at different windows. However, when this wave reaches all the windows, it again transitions to being just a regular ball, and it may transition at the window with the highest probability of being found. Thus the window which gets shattered is the point where the quantum ball spawns, while the rest gets only cracked. Similar to this probabilistic quantum ball wave, we can also associate a mathematical probabilistic wave to a particle, which is also called the wave function of that particle. And when this wave function collapses, that's when a particle truly starts to exist. A particle is an excitation in a quantum field. If you have acquired any form of schooling in your life, then you must have studied about fields at some point. A field is a concept used to study how an object can manipulate or influence the another object in spacetime, without any direct physical interaction. The most common example of a field is a gravitational field, which tells us how an object that carries mass pulls another object towards it that also carries mass, without any direct physical interaction. Another examples of a field would be electric field, a magnetic field, or simply electromagnetic field. Field concepts like these come under classical field theory, meaning all these field concepts are only used at macroscopic level. But when we use this concept of field at microscopic level, we call it quantum field theory, meaning it explains how particles interact with each other at microscopic level with the help of fields. And these fields are called quantum fields. And unlike classical fields, which often originate from intrinsic properties of matter, quantum fields doesn't originate from anything. Instead, according to quantum field theory, quantum particles themselves originate from a quantum field due to these energy excitations, or simply say energy bumps, which are quantized in nature. So to simply put all this, particles are quantized energy bumps in a quantum field. Particles might be one-dimensional strings. Yes, it means exactly what you heard. Particles could be one-dimensional strings that vibrate in a multi-dimensional space. And by multi-dimensional here, I mean more that for dimensions. That is your 3 spatial dimensions, and 1 of time. But unlike the spatial dimensions which expand indefinitely, this multi-dimensional space is finite in size, and is unobservably small. This small multi-dimensional space is compactified, or curled up into various complex geometric shapes, such as Calabi-Yau manifolds and orbifolds. The shape and size of these multi-dimensional space influences how the string vibrates, and the vibration of the strings determines the nature of the particles it manifests. For example, electron, photon, or quarks. That's it for the video.